Carbon is necessary for all life on Earth. Without it, life as we know it wouldn't exist on this planet. The carbon cycle is a process that redistributes carbon within and between the four spheres of the Earth: the atmosphere, the hydrosphere, the geosphere, and the biosphere. The carbon cycle works like this. As just mentioned, carbon is found in the air, in the water, in the ground, and in all living things. Plants absorb carbon from the air in the form of carbon dioxide through the process of photosynthesis. The plants store the carbon as carbohydrates and release oxygen through respiration. Animals that eat plants absorb the carbon that was in the plant's stores of carbohydrates. Carnivorous animals eat animals that eat plants, getting their carbon this way. Animals release some of this carbon back into the atmosphere through respiration in the form of carbon dioxide. The carbon remaining in the body is used to build tissue, used as energy, and used to perform the functions of life. As animals leave their waste materials, or as animals and plants die and decompose with the help of bacteria in the soil, the carbons in them are released back into the soil and into the atmosphere. The carbon released into the atmosphere recombines with oxygen and forms carbon dioxide. In addition, when plants and trees burn, they release some of their stored carbon back into the atmosphere. However, the charred remains also contain carbon. These charred remains will store carbon for a long time in the earth, slowly releasing it back into the soil and atmosphere, or they could eventually even be turned into fossil fuel. Carbon dioxide is continuously being dissolved into the seas and oceans through the process of diffusion, which is a difference in the carbon dioxide gas pressure between the atmosphere and the oceans. Just like on land, the carbon dioxide dissolved in water is used by marine plants as well as phytoplankton for photosynthesis. And just like on the land, the other processes work the same. The marine plants and phytoplankton store the carbon as carbohydrates and release oxygen through respiration. Marine animals that eat marine plants and phytoplankton absorb the carbon that was stored in them. Carnivorous marine animals eat marine animals that eat marine plants and phytoplankton, getting their carbon this way. Marine animals release some of the carbon back into the ocean through respiration in the form of carbon dioxide. Dead marine plants and animals sink to the bottom of the ocean. Decomposition then transforms their organic compounds into dissolved carbon dioxide, where it is stored in the deep ocean waters. Some of the dissolved carbon is converted into carbonates and bicarbonates. The carbonates are converted into calcium, which are then used by marine animals like corals, oysters, and other shellfish to make their shells. When these organisms die, their shells drop to the sea floor and eventually turn into sedimentary rocks, where carbon is stored. This sedimentary rock may eventually be turned into fossil fuel. When ocean surface waters warm up and cooler water sinks to the bottom of the ocean, this pushes up the carbon trapped at the bottom of the ocean to the surface, releasing some of the carbon back into the atmosphere, where it recombines with oxygen to form carbon dioxide. Fossil fuels are created over a long period of time, during which dead plant and animal materials deep in the ground are first turned into fossils and eventually fossil fuels through a high-pressure, high-temperature anaerobic process. Anaerobic meaning without oxygen. When plants and animals die and are buried deep in the oxygen-depleted environment, whether on land or deep in the ocean, and are then subject to immense pressures and extreme temperatures, they eventually turn into fossil fuels. However, this process takes over 300 million years, so the fossil fuels we use today started forming long ago. Fossil fuels are pumped out of the ground and then burned to run things like power plants, factories, and vehicles. More than 5.5 billion tons of carbon is released by the burning of fossil fuels each year. About 3.3 billion tons of this enters the atmosphere, with most of the rest being dissolved into the seas and oceans. Volcanoes are also responsible for releasing large amounts of carbon dioxide into the air through venting and eruptions. When volcanoes vent and erupt, they are releasing carbon that has been stored for a very long time deep in the earth, in the form of carbon-rich sediments, fossil fuels, and rocks. For this project, each of you will construct a soil respiration tester designed to capture the carbon dioxide released by microbes as they digest the organic matter found in soil. Here's what will happen during the experiment. As the microbes in the soil digest the organic matter, the waste byproduct will include carbon dioxide gas, which is released into the air. The carbon dioxide is collected and forced into the lime water solution. When the carbon dioxide dissolves in the lime water, it will form carbonic acid. The lime water, also known as calcium hydroxide, neutralizes the carbonic acid, and carbonate ions are formed. The carbonate ions then combine with calcium ions in the lime water, forming calcium carbonate. What you'll be watching for is the calcium carbonate. Calcium carbonate is insoluble and precipitates, which means it forms as a solid. As it goes through this process, it will cause the lime water solution to turn cloudy, and eventually white flakes of calcium carbonate will form. These should be clearly visible. As even more carbon dioxide is added, the hydroxide ions in the lime water solution will get used up and the solution will become acidic. This can be verified with a simple pH test.